for number 4, when you divide like terms, you subtract exponents. So if I'm going to do a to the 5th divided by a cubed, it's a to the 5 minus 3. Then for the b's, you subtract 6 minus 7. So that gives me a squared. 6 minus 7 is negative 1, so be the negative 1. But anytime you have a negative exponent, you flip it to the bottom. So a squared stays where it is because it was a positive 2. But the b to the negative first goes down to the bottom as a b to the positive first. And probably the answer key in the back of the book would say that's a squared over just b. So you don't have to write the 1. Either way is acceptable. For number 17, you keep the 3 because you're dividing like bases. And you subtract 9 minus 6. So that's 3 to the 3rd power, which means you actually are doing 3 times 3 times 3. 3 times 3 is 9, and 9 times 3, the final answer would be 27. Number 22, if you're going to simplify that quotient and write your answer in scientific notation, so what you can do is you can split up your problem. So this is a division problem because it says divide right there. So I can write 8.4 divided by the 4, and then this is times, and then I can do 10 to the 9th divided by 10 to the negative 5th. Well, 8.4 divided by 4 is 2.1. Then when I divide the tens, I keep the 10, but I do 9 minus a negative 5. So I actually end up with 2.1 times 10, and minus a negative is really plus a positive, so that's really 9 plus 5, which is 10 to the 14th. That is in scientific notation because 2.1 is a number between 1 and 10, and it's multiplied by a power of 10. For number 21, the x's are alike, which means I can keep the x and add 7 plus negative 6, and there's nothing I can do with the y to the negative 3rd. So I end up with x to the 1st, y to the negative 3rd, but you don't want a negative exponent in your answer, so the x stays where it's at, and the y goes down to the bottom. For number 80, which of the following is equivalent to x squared times x to the 0, you keep the x, and you add the exponents. So x to the 2 plus 0 is x squared. Number 20, you're going to write that number as a power of 10. So you have to take that decimal and move it all the way to the back, and you have to count how many times you move that decimal point. So you have to count all the zeros in between your two decimals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is like 1 times 10, and it would be negative 15, okay, because that number is very, very tiny, and that's why you need a negative exponent. But they just said write it as a power of 10. I put it in scientific notation, so just ignore the 1. So it's 10 to the negative 15th power as a power of 10. If I'm going to write 170 billion in scientific notation, the original decimal starts out at the end. It's got to end up between the 1 and the 7 to be 1.7, because 1.7 is a number between 1 and 10. Then I'm going to multiply it by 10, and I have to count how many spaces I moved it. So there's 3, 6, 9, 10, 11. This is a positive 11 because 170 billion is a very, very large number. That's why I needed a positive. On number 58, you're solving that by elimination. The nice thing is the y and the negative y have a positive 1 and a negative 1 in front of it, so I can just add these together and say 1x plus 1x is 2x. Y plus negative y gets eliminated. 8 plus 2 is 10. Divide each side by 2, and I get x equal 5. Then plug that 5 back into either original equation. I'm going to go into the first one, so 5 plus y equals 8. Subtract 5 on each side, and 8 minus 5 is 3. So I end up with x equals 5 and y equals 3. And of course you can check it in the second equation. Does 5 minus 3 equal 2? Yes. 27, if you want to simplify a negative exponent, you have to flip it upside down. So when I flip it, it becomes 1 over 3 to the positive 4th. And if I multiply 4 3's together, that's like saying 9 times 9. That's 81. So I end up with 1 over 81. Here, The d gets to stay where it's at because it's d to the positive first power, but the c has to move down to the bottom because anytime you have a negative exponent, you flip it.